Okay. So usually first I will explain what is the workflow again. So we are migrating data Oracle to Snowflake. So in between what we going to use. Okay. So Oracle to AWS 3 bucket. So in between they will use there will be separate ETL team. So they will push data into S3 bucket. Then after S32, we need to load data into Snowflake. So after that, we need to connect with the DBT. Then after that, we can share with data with BI tools. So this is workflow. In between, as per the requirement, they will use Python, SpyPark, Airflow for the scheduling. So this is so first we'll create Snowflake account, and we today we're going to see about theory. So what is Snowflake, and like what is architecture, and what are the micro partition, how the data going to store in the database, and what is the warehouse. Okay, so theory is very important. Okay? Then first we will create one Snowflake account creation. Just type in the Google Snowflake account creation. So sign up. It's taking time. So you can give your personal mail ID. Application for the job. So click on continue. So you can give company name anything. TCS. So job title Snowflake developer. Okay. So Snowflake comes in three editions. One is standard and enterprise and business critical. Okay, three editions: standard, enterprise, business critical. So in the standard, we don't have some features like security, like data protection, and there is one time travel feature we don't have in the standard. So and business critical, like for we have high security. So basically we go with enterprise edition. So if they ask in interview, okay, your company, what are the edition you are using for software, you can go with enterprise edition. Okay, this is one best choice. Okay, so there is one more edition, VPS, Virtual Private Snowflake. So when we are creating the account, we can't see that edition directly. If you want to get fourth edition, we need to request the Snowflake team. So they will give on the discussion. Okay, so basically when we create the account, standard, enterprise, business critical. So one more, fourth one, VPS, Virtual Private Snowflake. So in the interview they will ask, you need to tell four editions we have in the Snowflake. So what are the your project? What are which edition you are using? You need to go with enterprise. So standard for 1 hour taking $1. So for enterprise it will take $2, and for business critical it will take the $3. But VPS it will depend on the what type of data we are handling. So what is the security need for that? So maybe $5, $6, $7 like that it will. So that will be usually done by the like admin architect. Okay, that different. So always go with enterprise edition. Okay. Then Snowflake need one cloud provider. We have Microsoft Azure, Amazon Web Services, Google Cloud Platform. Okay, we are going with AWS. So it is since 2014. This one Azure 2018, GCP 2019. Okay. So region. So previously we have like Mumbai, India. So it's updated. Now we don't have the region, right? So we are going with Asia Pacific Singapore. Okay. So get started. So choose your preferred language, SQL. So continue. So you can skip these things. Okay. And so check the mail ID. So now we will receive one activation link. Okay. Wait for take some time. Okay. Fine. So if not, I mean, it will give sometimes it will take time. No problem. You can go. So I will go with these. So basically, so we have the four editions: standard, enterprise, and business. Okay. Here standard it will take uh, like for $1, and enterprise it will take for 1 hour. So $2. Business critical it will take $3 for 1 hour. So one more VPS, virtual rate Snowflake. So this one on the discussion will go like $5. So maybe $7. Okay, we need to discuss with the Snowflake team. Okay. So Snowflake is like pay as use model. Okay. So no need to pay if you don't use the data. So what we use? So we need to pay for that. Okay. So and so one more thing, it is a SaaS model. SaaS model, software as service. Service. Okay. Means no need to install anything. Okay. No need to install anything. Software service, SaaS model. Okay. Then check again. Okay. So I use it to create many accounts. Okay. Uh, So first, what is the priority like? So first we need to have the one warehouse, then database, then schema, then inside we have tables. Okay, we use like we use okay. So different data we have. Okay, we received the account. So this is we will receive one link like this. Okay, the activation link. Click to activate. So this is username. You can give anything. So I'm giving Madhu server. So password you can choose. Okay, just give your name and give some numbers. The data. So 1 2 3 4 5 6 7 like. Because of we're going to use password. If you want to connect with SnowSQL command line, or if you want to connect with the DBT, we need this username and password. So this is your interface. Okay, we can skip for now. So here we have this button like project, application, transformation, AML, monitoring, marketplace. So where we going to work? Here you can see home button, this plus button. So we need to click on plus and you can see the SQL file. So this is a worksheet, okay, where we're going to work. Okay. So we're going to create a warehouse and database schemas, tables in this interface, SQL file. So these are the sample database we have Snowflake, Snowflake Learning DB, Snowflake sample data, some user. So we can run the command like show databases. See this one. So Snowflake. Snowflake learning and Snowflake samples. So user one. Okay, these are sample database. So you can have data inside this schemas. Okay, for practice purpose, we can use those data. So by default, we have one compute warehouse and a Snowflake learning warehouse and some system streamlit notebook. Okay. So by default, we have these warehouses. Okay. So these are roles. Now I created the account. I am the account admin. So there will be organization admin, public, security admin. Okay. Snowflake learning role, system admin, user admin. So these are rows. Okay. So we need to choose one database. So these are database, but here we're going to create our own database, our own schema. So first we're going to create the one schema. So one warehouse. Then after that we will create. So I'm creating one. Okay. So here I'm going to create trans warehouse. Okay. So here simply to create warehouse, create warehouse. Okay, warehouse name we can be. So it's going to create one warehouse. Okay. So this is not proper way to create the warehouse. Okay, in real time. So we need to mention everything. Okay. So create warehouse trans. So warehouse size we need to mention. Okay. So usually we have small, medium, large, 2x large, like that we have warehouse. I will show you. And warehouse type like standard warehouse. Okay. Then minimum cluster count 1. So maximum cluster count 5. So it's going to use clusters in between 1, 2, 3, 4, 5. So as per the workload. So okay. So auto suspend equal 300. It means like so 300 seconds or 5 minutes. So you are not running any queries or you are not creating tables. So you are not using this warehouse. Then by default it's going to suspend after 300 seconds. So this is one advantage in the Snowflake. Okay. So auto resume true. So when you start running queries, then it's going to active. Okay. So this is real time. It going this warehouse and database schemas going to created by the admin. So not you, but we need to have the knowledge how to create a warehouse. Into they will ask, have you created a warehouse in your work? You need to say no, but I know how to create a warehouse. Okay, because of you are the developer, so you don't have permission to create the warehouse. Okay, it will done by the only admin only. Okay, so that's why you need to say let me the admin. So I know, but I can create the warehouse. I know how to create it. You need to tell like that. Okay, this one. So I'm trying to create showing object trans already exists. Okay, so we can use create a replace warehouse trans. Okay, yeah, see, take it. So for running this one, you can see run button. You can click on that, or you can use in keyboard control enter. Control enter. It's going to run. Okay. So now I have we are in the trans warehouse. It is a small warehouse. Okay. So in project, so what type of warehouse you are using? So like what is size of your warehouse? You need to go with small, medium, large. Okay, Intel. So we are using only small warehouse. So as per the requirement, when we are loading large data, then we will go with medium and large warehouses. Okay, you can tell only the small warehouse only we are using in our project. This one. Okay. So this is trans warehouse. Okay, we are creating. Then I'm going to create one database. To create database. So for our database. So this is the how to create the so database. Okay. So now create one scheme. So I'm going to create one sharp scheme. So this is the database and schemas. So you can run the command show database. So it will show the these database. Okay, we are having raw database and show schemas. So it will show the schemas. Schemas. Okay. So then run show users. So Madhu is okay. This is my username. So when it's created and login name, display name, first name, last name. So and which mail ID we use. Yeah. This. So this is going to use this one. Okay. So default warehouse, compute warehouse. Okay. So default role account admin. I'm going to show. Okay. This one. So owner account admin. So I'm the owner. So that's one. So we'll have different parameters. Okay. So if you want to know anything, we can use this command show database, show schema, show just like that. Even show tables. So it's not showing any tables okay, because we don't have any tables. So I'm going to create one table. So create table. So apply this one. Right? So imply ID. So the data type like int. Okay. So imply name. We use varchar. We can use string for numbers. Already I think you both know how to create the table. Okay. So int number float. Okay. Those we're going to use for numbers. For alphabetical, we're going to use the varchar. Okay. And salary, we can use float. These are okay. These are it. Okay. Three columns we created. Employee ID, employee name. So salary. This one. So I'm going to insert some sample data, insert into employee. So values. You can give like one. Uh, so this. To control enter. So the data going to insert into the table. Okay. Insert some table. Okay. So now we have the table. Select start from employee. So this is the table employee ID, employee name, salary. Okay. Now select start from employee. So where ID equal to what is where employee ID equal to what. Okay. So now we get filtering that. Okay. So I created table. So I inserted some data. Then I selected data with select star by employee and I run query like select star by employee where employee will equal to 1. So it given data. So how it is going to happen behind. Okay? So that I will explain now. So for this one we need to see what Snowflake architecture. So no worries, I will share the notes. Okay, that notes you have everything. So this is the Snowflake architecture. Okay, so we have three layers. Okay. So one is database storage layer, and here we have compute layer or query process layer. We can call it and cloud services. So when I create table and I insert data, so those going to store in this layer, database storage layer, even that is structured data, semi-structured data, and unstructured data. Okay? So the data going to store in this layer. So in compute layer, so select star from table name or select star from uh, table name where ID equal to. So the query going to run in this layer. Okay. In this we have virtual so variables. Then in cloud services layer, so if you want to log into Snowflake account, so we need to have the username and password. So those about security, you're going to take care in the cloud services layer. Okay. like security, management, metadata, optimization, authentication services. Suppose you want to connect with any DBT, you want to connect with Power BI. So those security purpose, so everything will be done in the cloud services layer, even metadata. And okay, uh, if you create a table, okay, every table having some metadata, right? So those data going to store in this layer, okay? And it's like brain of Snowflake. So it is like a, engine of the Snowflake, and it's like base of the Snowflake. Okay. So in compute layer, so we have so virtual warehouses. So I created one trans warehouse, right? So this is like one trans warehouse. So this is one compute warehouse. So this is one more warehouse like that. So each warehouse is independent. It won't depends on other warehouse. Okay. It won't depend. Each warehouse is independent. So what is warehouse? Like a set of multiple clusters. It is set of multiple computers. Computer is nothing but a set of virtual is nothing but virtual. There is nothing but it's set of multiple computers. So it's having the RAM, memory, SSD, CPU, everything in the virtual warehouse. Okay. So, so how the data will be stored in this database store layer? So the data going to store in the micro-partition format. Micro-partitions in the column format. Column format. Okay. So virtual warehouse. Okay. Virtual nothing but so I will explain. Okay. So first we will go with one more thing. There is micro-partitions. This. Okay. So how the data will be stored in database storage layer. But how it going to store in the format of micro partitions? Okay. It is a column format. See, this is the okay. This is the okay. In this format, the data going to store in the Snowflake. Okay. So first, this is table. So logical structure. In the table we have type, name, country, date. Okay. So this is the physical structure. So this is micro partition 1, micro partition 2, partition 3, and partition 4. Okay. So this is the table. Logical structure. Directly we can see in the directly in the warehouse we can see select star from table name. So you can see data like this. But in the physical structure behind, so the data going to store like this. Suppose you can see. So we have 24 rows here. So here partition 1 we have 6 rows, partition 2 we have 6 rows, the partition 3 6 rows, and partition 4 6 rows. We have like this. Totally 24 rows. So type going to store this one 2 here and 4 here and 3 here. Okay. See again 2 3 2. So 2 3 2. The micro partition we have type in this going to 6 rows. Those type values are going to store here. So again like that name, country, and date. Okay, this one. See and again see and so SF for yeah, 11 by 2 here. It's more like 11 by, and this SP stored here like so. This is the partition. So now I created one table so that the data storing in the partitions. Okay. So after some time, now we have only 24 rows. 24 rows. Okay. So after some time, I am going to insert some more rows. Maybe 100 rows. So now what will happen to these partitions? Now Snowflake what will do? So again it's going to rearrange the partitions. So it's going to rearrange the partition and then it's going to create new partitions. Remember this point into they will ask. So you have a table 100 rows and having the micro partitions. But sometime so we will receive some more data, right? We need to we need some data. So then what will happen to those partitions? Now the Snowflake will do automatically. It going to rearrange the partitions. Rearrange the partition. This is first thing. So why we need partitions? So So in other database we have like indexes concept, right? Indexes concept. So in Snowflake we don't have index concept. So instead of index, so we have micro partitions and cluster key. Okay? Micro partitions and cluster key. Here, suppose having like here having like 2 lakhs rows. So here partition one, 50,000 rows, partition two, 50,000, 60,000 to 1 lakh. Here 1 lakh to 1 lakh 1 to 50,000. And here 1 lakh 51,000 to 2 lakhs. So when I run the query, select star from where ID volt, uh, like 1 lakh 60,000. So it's not going to scan the entire all partitions. So directly go to the micro partition. Because here we are storing 1,51,000 to 2 lakhs the partition will store. So it will go to this partition directly. It will check, it will scan this partition. It will give the data. So this will happen when we run the query. Okay, because it will happen. So this is one. So, and one more thing, the Snowflake knows when we are setting data, it knows, okay, how the data inserting, like, so what is the minimum value, what is the maximum value, okay, and what is the count, okay, it know. So directly, suppose I'm running one query like select star from maximum salary from table name, the Snowflake not going to scan the entire table. So directly it will fetch the maximum salary from the table. So because of Snowflake knows when we going to store the data, each field it knows where the maximum values, minimum values. So what is the row count? So it know the Snowflake knows directly. So that's why it won't scan the entire table. Okay, entire table. The Snowflake knows everything. Okay, see the table consists of 24 rows stores across 4 micro partitions. So with the rows divided into equal between each micro partition. So within each micro partition, the data stored by column. So which enables Snowflake to perform the following actions for queries to on the table. So prove first to prove micro partitions, okay, and then prune by the column with the remaining micro partitions. Okay, means so we have prune means nothing but query pruning. So query pruning means so when we are writing the query, so it will scan only relevant data. So it won't scan the unnecessary data. So that we can call the query pruning. So query pruning nothing but Snowflake only scans the relevant data. It won't scan the unnecessary data. Suppose if you run any query, uh, select select star room table name where city equal Hyderabad. So then it going to scan only it will relevant data. So it won't scan the unnecessary data. It means like Snowflake, it won't scan the unnecessary data. It's going to scan the relevant data. So that we can call query pruning. Okay? Even Snowflake knows what is the minimum value, what is the so maximum value. Snowflake knows, okay, everything, maximum and minimum and count of rows in the table. So that is the Snowflake. Okay, how we do it. So it is a column format. We are loading data in a column format, right? So the data going to store in the column format. Column format. In this format, the data going to store. So in compressed format. So in each field, it can store up to 50 MB to 500 MB in a compressed format. So in each field, it's going to store 50 MB to 500 MB in a compressed format. Remember this part. In a compressed format. So this is for the data how we will store in the Snowflake, the format of micro partition. Suppose if I am going to insert new data, it's going to rearrange the partitions. For the every table, we have logical structure, we can see directly. So physical structure we can't see directly, but it's going to store like this in the database. Okay. So this is about. So where this partition going to store? This partition going to or in the format metadata, the cloud services layer. Okay. The cloud services layer. We have architecture, right? So the metadata going to store the metadata going to store in the cloud services layer. In the cluster. So we don't have the indexes in the Snowflake. Now, how is going to do the performance tuning when we run the query? How it's going to fetch the data pick here? So cluster key nothing but, so when we are creating the table, in that time we can mention the table creation syntax, or we can use the alter. We can apply on the column. So cluster key nothing but, so I have, we going to use cluster key and only the larger tables. So I have larger table having the millions of rows. Okay. So in that rows, in the table I'm going to run some queries. So on that query I'm going to use this date column many times. I'm using the date column. Okay. Or I'm using the country column. So many times I'm using the country name in that query, or the date name in that query, the date column in that query. I'm using the many times. So in that scenario, so first condition, the table should be large. One more thing, and we need to repeatedly use that column so many times. So in that scenario, we going to use the cluster key. So when we use the cluster key, it's going to perform very better. Okay, so that is the cluster key. Okay, cluster key. So there is no limit. So we can apply cluster key on every column, but we don't apply like that. Okay, there is no limit. Okay, we can apply. They will ask in the interview how many cluster keys you can create on a table. So you need to tell, okay, so we can create, there is no limit to the cluster keys. But if you create more cluster keys, so there is no useful. There is no useful, okay. So on the one table, there is a large table. So we're going to create cluster key on only, so one column, two column, three columns. So we do not going to use more than three columns. Suppose if you're using cluster keys more than three columns, there is no use of it. Okay, remember maximum in your project, have you created cluster keys? So on how many columns you can go with? So one or two columns only. Okay, so don't tell more than three. But there is no limit. We can apply on every column. But if apply, there is no use of cluster key, and it will take some cost for that. Some cost. Okay. So again, it will be delay in the running the query. Okay. Usually we need to apply only one or two or three, maximum three. So you can tell one or two clusters only applied on the table. That is cluster key. You no need to apply in the smaller tables. We need to apply only larger tables, and that column should be repeatedly in that query. Okay, and the SQL statement going to repeatedly we're going to use that column. So on that scenario, we are apply the cluster key. So one thing, so we don't have the indexes. Instead of indexes, we have micro partitions and the cluster key in the Snowflake. Okay, remember. Okay, just know about only cluster key. So they will ask you about, they don't ask about this cluster depth. Okay, overlap. Okay, this unnecessary things. Just remember cluster key we need to apply on the table. Okay, so this is by default it will done by the Snowflake. So we no need to know about like that. Okay, cluster depth. Okay, remember only cluster key, that is enough. And even they don't ask for the cluster depth, that is different. Okay, that will done automatically by the Snowflake. So this micro partition we are not going to create. So by default automatically it will done by the Snowflake only. Snowflake. Okay. So first question they will ask about layers, explain about layers in the Snowflake or Snowflake architecture. So database storage layer, compute layer, cloud services layer. And again, they will ask the micro partitions. Then they will go with cluster to this one. So in the format of micro partition, the data going to load in this. So database storage layer. Okay. Here the queries will be run in this layer. And the cloud services layer will take care of the complete security management. So metadata, optimization, everything is done in this cloud services. So the data will be stored in the micro partitions. Okay. And each field having like 50 MB to 500 MB. Okay, each partition 500 MB. Okay, in compressive format. It is a column format storage. So when the data, see the data sorted and sorted by the column. Okay, it is a column format. So remember these things. Okay. So next we go with multi-cluster warehouse, and we're going to see about so how this virtual warehouse. Okay, when we go with small, when we go with medium, when we go with large. So what is 3x, 3x, 4x large? We're going to see those. Okay. So same link. Okay. We can region with the same link. I'm ending the meeting. So now we can need to region with the same link. Okay. Yeah. Region with the same link.